Let's answer the question, what is router on a stick? In traditional routing, we've learned that each router's interface is connected to a subnet. For example, this router has two interfaces. The interface F10 is connected to subnet 10 with the address 10.0.1.0/24, and the interface F20 is connected to subnet 20 with the address 10.0.2.0/24. In order to forward an IP packet from one subnet to another, the router needs to encapsulate the IP packet into the layer 2 frame of its interface in the destination subnet and forwards the frame. For example, to forward an IP packet from subnet 10, the router needs to encapsulate the IP packet into the Ethernet frame and forwards the frame out of the outgoing interface F20. This allows an IP packet to travel from one subnet to another. In Vlan routing, we've learned that each Vlan is a subnet. Typically, the devices in Vlan routing are connected as in this diagram, which shows us that only one router interface is connected to the switch that has multiple VLANs. So the question are, what VLAN configures on the switch interface that is connected to the router, and how an IP packet travels from one VLAN to another VLAN? To answer the first question, we've learned that on a switch, a chunk port is the port that allows multiple VLANs to travel through. Therefore, the switch port that is connected to the router's interface must be configured as an 802.1q chunk port. To allow an IP packet to travel from one VLAN to another VLAN on the Cisco router, the physical port must be configured with multiple logical sub-interfaces using the same VLAN chunking protocol 802.1q as configured on the switch interface. The sub-interfaces are then associated with the VLANs and assign IP addresses. These IP addresses are the default gateways of the subnet. The configuration is called router on a stick. Here is how PC1 in VLAN 10 sends an IP packet to PC2 in VLAN 20. Since PC2 is in a different subnet, PC1 encapsulates the IP packet into an Ethernet frame and forwards it to the default gateway 10.0.1.1. When the frame gets to the switch forwards it out of the chunk. The frame then gets tasked with VLAN 10 information before sending, and it is delivered to the sub-interface F00.10. The router removes the tag and decapsulates the frame to get the IP packet. Based on the destination IP address in the IP packet, the router encapsulates the IP packet into a new Ethernet frame and forwards it out of the sub-interface F00.20. The frame then gets tasked with VLAN 20 before sending. When the frame arrives, the switch removes the tags and forwards the frame to PC2, which completes the VLAN routing process. Let's read the keynotes for this lesson. This is the end of this lesson. If you have any questions, please put it in the comment section. Thank you very much for watching.